Hello everyone, my name is Aldo. I'm here as one of lecturer of robotics and artificial intelligence in Faculty of Advanced Technology and Multidiscipline, University of Erlangen. I want to present a short academic course series for a sustainable energy and green technology application 2025 event. My course is a multicopter drones, technical principle, application in green technology and safety procedure for supporting sustainable tourism. In my presentation, in my lecture, I want to explain about the drone in general and the term of drone UAV and the more specific about multicopter or multicopter. And before we focus on flying mechanism and the construction and all technical details about drones, I want to explain to you about safety flight procedure. Yeah, so that is come first, and after that I will explain to you flying mechanism, construction of the multirotor, how it can fly, the physics behind it, the propulsion system, the power system, flight controller, sensor used, and how it can stabilize, and so on, and also the software, the platform that open source, yeah, and the application in green technology or agriculture application in the end.
Okay, first we want to talk about drone. What is a drone? A drone is an unmanned aircraft. Drones are more formally known as unmanned aerial vehicle or unmanned aircraft system. There are two words meaning for drone than a multi or a monotonous sustained word. So a buzzing word that kind of like a drone. And sometimes many common people very confused between drone and UAV. Still in the confusion between drone and UAV, there are several terms and abbreviations that commonly used in aviation. Yeah, so we know UAV, UAS. UAV is unmanned aircraft vehicle. UAS is unmanned aircraft system. RPA is remotely piloted aircraft. And maybe you most commonly hear the term drone used by the media and military, and UAV used most often by the FAA. But actually, the words drone and UAV mean the same thing and can be used interchangeably. Both are aerial devices that can fly with a human remotely controlling them, or in the most advanced cases, it can fly by themselves without any human intervention. There are rotorcraft system, fixed wing system, hybrid system, biomimetic system that articulate the living things, a lighter than air system like a balloon. Yeah. There are so many drones or UAV. But in this presentation, I will focus on the drones. I mean, the multicopter. Why I why I keep saying drones? Because the popular perception of drone is a multi-rotor multicopter. Yeah.
Now we want to talk about the drone safety and flight procedure. So this is very important before we walk through on the uh, technical side of the drones. I want to introduce you and explain to you the drone safety and flight procedure, how to fly the drone safely, especially in Indonesia, the regulation, best practice, and safety tips before you fly the drones, and why we have to follow drones regulation in Indonesia. First is safety. We want to avoid accident with people. We want to avoid collision to aircraft and another other properties that may cause some risk, may cause some effect, and maybe some loss. And second is legal compliance. We want to prevent fines or confiscation by authorities, because we have the rules, we have the regulation here in Indonesia, and also we want to respect privacy and culture. Yeah, we want to avoid something that maybe make local people not really cool with that. Yeah, and I want to explain a bit that Indonesia have a regulation from Directorate General of Civil Aviation, uh, uh, actually, there are so many rules about drones, but I cannot explain to you all of the rules. But some points are really important to explain here. First, here we can see that the drones more than 2 kilograms must be registered with DGCA or DGPU. Yeah. Why? Because the more heavier the drones, it can create more risk. Yeah, the collision will create more risk if the drones heavier than 2 kilograms. So, this is a very important rules. Yeah, especially when your drone is bigger. Yeah, and no fly zone. Yeah. This is also important. Yeah, so we cannot fly the drones 5 kilometer radius near airports. And we also cannot fly the drones on a military basis, government building, and crowded areas. Yeah, and also heritage sites like Borobudur, Prambanan without permission. Other than that, private area also no fly zone as well. So sometimes you have to get a permit. Yeah, you have to get a permit to authorities for flying drones. And this is also important. Yeah, you have to fly your drones with maximum height, yeah, maximum altitude 150 meters. Yeah, some rules says 120, some rules says 150. According to the DGCA, it's a 150 meters. Yeah, but I think it is better if you keep the altitude below 100 meters. That is a safe altitude. And also you have to lock the visual line of sight. What is this mean? A visual line of sight. It is the place of your drones, or the location of your drones must keep on the your side at all times, so you can see your drones directly. That is very important. You have to keep that. Yeah, if your drone not on your side directly, it is forbidden. Yeah, actually it is forbidden to fly the drone like that. Well, like that way. Maybe it is different with the FPV application, yeah, because you have to put some goggles, yeah. But that kind of drones must be flight in some areas that really specific, yeah. So for the general rules, you have to keep the visual line of sight of the drones, especially for a commercial use, for taking a picture, yeah, drone, something like that. And this is the maps, no fly zone maps. Yeah. And this is you can see here there is an area here. So this is area of the airport. This is the area that not allowed to fly the drone. But not all of them is no fly zone. But there is a rules. Yeah, we can uh, see here there is a red area. It is a restricted zone. So this one, yeah, restricted zone means you absolutely cannot fly any drones there. It is restricted, yeah, because this area, this air area already used for air traffic, air traffic for airplane, yeah, for airports, and also altitude zone like this one, yeah, altitude zone. So the altitude zone has a bigger radius. Yeah, it is depend. You can see that on no fly zone. You can found no fly zone map on the internet. It is easy. You just google it. Yeah, so this is the altitude zones. And warning zones. Yeah, warning zones is the area uh around the authorization drones. Yeah, so authorization drone is the radius of your of the airport. Yeah, and More than that is some warning zones. Yeah. So sometime we cannot see the warning zones, but warning zones not uh you in the warning zone actually you can still fly the drone, but you have to be careful because it is really near the authorization zones. In this zone, yeah, which appear like a blue areas, uh, flight is really limited. Yeah, maybe you can just fly your drone only 5 or 10 meters height. Yeah, uh it is locked by the system. For example, if you are using a DJI system, yeah, so you have to unlock that with the authorized users. Yeah, so you have to log in and verify your account. Yeah, so on authorization zones you can fly the drone. So and before you fly the drones, yeah, there is a pre-flight checks. Yeah, you can check the battery first. Yeah, and the weather. Yeah, check the battery and the weather outside, how bad it is it good or not. If it's the weather is good, yes, so it's good to go. Yeah, verify GPS and signal strength. Yeah, you have to make sure that all of the system of the drones, they are have signal strength and GPS counting. Yeah, so if your GPS is more than 20, I think it's good to go. Yeah, more than 20 or 30, it's good to go. And inspect propellers and motors. Check the condition of the propellers. Is it cracked? Is it in good condition? Or is it bending or still straight? Yeah, you can see the propellers and ensure no fly zone compliance. Yeah, so for example, if you are using a system like a DJI, you can just see the warnings. Yeah, are you in the no fly zone or not? Yeah, but if you are using custom multicopter, I think you have to uh, learn more about the aerospace. Yeah, so you will not get into trouble. Okay, and if needed you have to carry your drone license. Yeah, so in Indonesia there is a drone pilot license. If required you have to show that if something happen. Yeah, make sure safe distance to drone when take off, so around 5 meter to 20 meter according drone size. Bigger the drone, so you have to put a distance before the drone take off. Yeah, but if you are using a very small drone, like for example like uh like your thumb, yeah, the drone size like your thumb, I think it is okay. Yeah, if you just fly it uh, on your palm like that. Yeah, because it's just a small toys. Yeah, it's all right. But if it is a professional drones, I think at least 5 meters uh horizontal distance to your drone before takeoff. And some warning for you guys. Yeah, first I think this is very important. You if you have signal loss, yeah, you just make sure that you enable return to home uh fail-safe system. Yeah, all of drones now have this kind of fail-safe system. Yeah, and for the battery low, if you have a warning for a battery low, you maybe you already set the percentage or the voltage. Just follow the rules. Yeah, follow the warning. Yeah, if you have a warning for a battery low, just land immediately. Yeah, and interference. Yeah, we have to avoid flying near power lines. Yeah, because it can cause the signal loss. It can cause the drones will behave strange. Yeah, so I think it is better. Yeah, or I think it is mandatory to avoid power lines. And for the collision, yeah, it is really important. Yeah, because the collision from drones can, for people, yeah, it could be very seriously dangerous to people. Okay, because many drones not using like a propeller guard, yeah, and it can harm you, yeah. It can harm you, maybe if it collide to you, collide to your head, like in this picture, it can cause harm, yeah, it can cause injury, yeah. So make sure you have to avoid the collision, and the first thing that you have to avoid is people, yeah. Yes, so I think this is a tips for you. Just make sure that if you can avoid fly your drone in a crowded area, yeah, it is better, yeah. Just avoid the crowd area, yeah. But if you are really sure the system, yeah, the scenario of your flight, and you already put a good setup, and you just already make sure the task of the drones, yeah, it is all right, yeah. And but I prefer to avoid fly in on top of a crowd area, yeah. Okay, I think that's all for the tips and the safety procedure that you have to follow, yeah. Actually, there are so many rules that you have to learn if you want to know more about the safety procedure for the drones. But I think I already pointed the most important thing uh, for maybe for amateur or for a beginner, yeah. But if you really interested to be a drone pilot and do all the procedure that very safe, and you want to, especially if you want to fly the drone for a commercial purpose, I think it is better to you for uh join the certification, yeah. Maybe in your country there is a certification, yeah, and there will be a bunch of material that you have to read as a drone pilot.
So we will focus on the multirotor or multicopter. While the commonly known helicopter has one rotor, the multirotor is a one unique kind of aircraft that is equipped with two or more motors, not only one, but two or more motors. In this course, we will introduce you to some popular types of multirotor and explore the pros and cons of this configuration, the principle, and also the application in the end. And it's really known with its practicability, maneuverability, because it's become popular as toys, photography, and for racing, and for recreational purposes. But also, this aerial robotics platform is very useful for any kind of custom task. Okay, and the multicopter, there are so many, and we will discuss it by one. The copter could be the cheapest multicopter configuration to build among all because it only uses two motor and two servos. But it also most difficult platform to stabilize in flight. It has least lifting power given that it has a least lifting power given that the fact that it only has two motor and also need two servo. And the tricopter, uh, based on the name, a tricopter, it has three rotor and typically in Y shape, sometimes in T shape. It has a 120 degree, sorry, apart between the leg, and on the back it has a servo to tilt the rotor, so it can stabilize. That why it can stabilize. And next is the most popular configuration is a quadcopter that has four motor mounted on a symmetric frame, and each arm typically has a 90-degree apart for the X4 config and plus config. So in the right is a plus config, on the left is X config. Two motor rotate clockwise and counterclockwise, and the other rotate counterclockwise. Yeah, so there are clockwise and counterclockwise to create opposite force to stay balanced. Yeah, so there are X and plus. And the X config, It's more popular as you can keep the propeller out of the camera view, yeah, because you can put the camera in the front, and it's really nice to have the view, yeah, because it's uh, not covered by the rotor itself. And how quadcopter fly? Yeah, well, the propeller spins, yeah, push air down, and similar to helicopter, pushing the air down is the action in Newton's third law of motion. The reaction is a force called lift, yeah, and which pushes the quadcopter up. Each of the propeller will create a lift, and the total lift for the quadcopter will be the sum of the four propeller. So it to make it fly, the total force of the lift must be stronger than the gravity itself. Uh, so that's why it can fly. And how it movement, yeah, the lateral movement occurs by varying the speed of the propellers, increasing the speed of the two propellers on the one side, yeah, so for example on the back, and decreasing the speed of the two propeller on the other side creates uneven amount of lift on the two sides. And the lift, yeah, the uneven lift is created on the side with the faster spinning propellers is greater than the lift created on the opposite side. The result is that the quadcopter moves the direction of the side where less lift is created. So, for example, yeah, this is the less lift, yeah, it will move on the right. And how quadcopter maneuver? Yeah. So the variation between the rotor, yeah, we know that if we want to move down, just lower the speed, higher the speed if you want to move up, move forward and move backward, just varying the front and the back rotor. Yeah, roll control, it's the same. Yeah, only left and right uh, motor. Yeah, and the yaw control, it is interesting because we have to uh, make a higher speed on the two rotor blade, yeah, and higher speed on this diagonal on two rotor rotate right. Why it can yawing or it can rotate because the inertia of the motor. And how do multicopter stabilize? Usually, because it has a sensor, usually IMU, inertial measurement unit sensor that consists in the drone, in the multicopter. So usually IMU consists of following sensors: three-axis accelerometer, three-axis gyroscope, three-axis magnetometer. Yeah, so the accelerometer to measure acceleration along its axis, gyroscope measure the rotational velocity around its axis, yeah, the rotational velocity, and the magnetometer measure the local magnetic field, so it can uh, distinguish the what the drone heading to. And this is the airframe that usually used in a multicopter. There are quad, already mentioned it before. There are hexacopter, hexa using uh, six rotor, and there are also coaxial configuration that I will explain it on the next slide. Hexa Y, hexa IY, yeah, octocopter using X configuration, but it has 8 motors, and also octocopter with this kind of configuration. And so there are many configuration because it depends on the project or the application of the drone. It also depends on the stability that you want to achieve more motor, more stable. Yeah. If you want to achieve more motor, if you want to achieve a stable, more stable, you have to put more motor. And for security, more motor means more secure. Since the system can manage if one of a rotor fail, it can stabilize by centering the thrust system. So this is the example of coaxial configuration. Yeah. There are two rotor that put on the same axis, up and down. And yeah, we have a closer look on the coaxial motor arrangement. Advantage of the coaxial motor arrangement: first is a redundancy for security. If one motor fails, the aircraft can still maintain balance in the air and allow it to land safely. And it's also save space. And using coaxial motor can create a better design for fall level. And the disadvantage is the power efficiency. Yeah, because some of 1 to 10% to 20% loss in power efficiency because uh, the bottom motor is just turning already sped up air, so it's losing efficiency there. And propellers can get caught by obstacle more easily as pilot could oversee them. Yeah, because the propellers are located above and below the arms, they are hard to hide from the camera view. That is the disadvantage as well. So it's not ideal for a camera view. And this is the multi-copter frame. And this is the example of multicopter frame. Common material that uses carbon fiber, epoxy fiber, ABS plastic, and sometimes they are using aluminum as well. Yeah, yeah, and I think the best you can use is the carbon fiber, but you have to sacrifice the price of the carbon fiber. Yeah. And this is the frame size. The frame size is, I think, very important. Yeah. The size will be parameter to decide the proper size as well. Bigger size has bigger motor, bigger battery, and heavier lid. Yeah. So how we determine the size? Yeah. So we can determine the size with the diagonal length here. Yeah. We can measure the diagonal length, the diagonal distance, which is the length between the axis of rotor diagonally. So this is the frame size. You can see it on the table that the bigger frame size, bigger propeller, bigger motor, and bigger battery as well. And next we moved on the basic about battery to for drone. Yeah, the basic about lithium polymer battery. Usually drone using a lithium polymer battery because it commonly used because its C rating. Yeah, it can draw so huge current. Yes, so huge current charge, and it has a high energy density, and we will discuss about it. So, in the drone, what information that you have to know about battery is a battery voltage and cell count. So the cell count, so this is the example, the diagram, yeah. The cell 1, cell 2, cell 3, cell 4. So it is a 4-cell lithium polymer. And this is the arrangement for 2 cell. Yeah. Lithium battery access in a cell, yeah. Each cell has 3.7 volt. If higher voltage is required, this cell can be connected in series for form a single battery. And we don't normally refer to battery voltage, yeah, so we call it cell. So when you are into the drone, yeah, you are the um, on the drone community, they usually call it cell, not the voltage. And this is the LiPo battery capacity and size. Yeah, for example, you have a 1013 milliampere hour LiPo. Yeah. It will take an hour to be complete discharge if you draw a constant 1.3 ampere current from it. And if you draw 2.6 ampere, the duration would be half. Yeah. So that's the calculation. If you draw, for example, all of the motors draw 39 ampere of the current non-stop with 1300 milliampere LiPo, you only get 1.3 per 339. It's about uh, 1 per 30 of an hour. It's only 2 minutes. Yeah. Yeah, and the milliampere is basically an indication of how current you can draw from the battery for an hour until it's empty. Yeah, that is the key point. And still on the LiPo battery, increasing your battery capacity might give you a longer flight time, but it will also get heavier in weight and larger in physical size. As the battery gets larger, the increase in flight time becomes ineffective. Eventually, it will reach a point where it just doesn't gain any more flight time with a bigger battery. Yeah, so when you push the battery bigger, the size bigger, and you will not get a better flight time. It will stack. It will stuck on the some flight time. You have to get a more density battery, I think. And when it's time to land, so we have the graph here. This is the full charge, and the 30% to 40% is the area where you have to worry, where you have to put attention on your drones. Yeah. And because after the 5%, yeah, about 3.5 or 3.6 volt per cell, it will drop. Yeah, it will drop. Wow. So it will drop to create zero voltage. Yeah, maybe it will create a zero voltage, and it's very dangerous for the aircraft. Yeah, because if it pointing down like this, yeah, the voltage will be drops, and the system will shut down, yeah, and it will fall. Yeah, the drone will fall. And we move to electric propulsion system for aerial robotics. Brazos DC motor is a synchronous motor using a direct current electric power supply. However, it runs like AC motor, but because BLDC gets three-phase voltage source from ESC, so that runs on DC voltage. Yeah, actually, it has a three-phase like AC motor, but the source is a DC voltage with a motor controller. And this is the brushless DC motor. You can see it on the picture. Actually, this motor is commonly used on every area, in many area. Uh, it used for computer hard drive, electric vehicle, electric bicycle, industrial robot, washing machine, blowing fan, and so on. Yeah, there are so many applications of brushless DC motor. Oh, sorry, the wider stator has a larger moment of inertia. That's why wider stator now is very popular. But the advantage of wider motor is better cooling as well, thanks to larger surface area. The wider stator also allow a large bearing to be fit. So large bearing are better efficiency, smoothness, and longevity. But the taller stator give you instant acceleration because the inertia is low. And the BLDC motor, we will hear kV on a BLDC motor. So the BLDC motor kV is very important because higher kV motor have shorter winding that does lower resistance. It lowers maximum voltage rating and increases the current draw for the motor and propeller. And generally speaking, the heavier multicopter usually have lower kV motor. Lighter quadcopter usually using high kV motor. Yeah, so that's why it's connected. Yeah, the revolution per volt. Yeah, when you found 850 kV, you will rotate the motor 850 RPM per volt. But with the lower kV motor, for example, this one has 29 kV. Yeah, 29 kV, you will get 29 kilo RPM per volt. And this is the motor thrust chart. Yeah. This is very important when you are designing a multicopter. You will take a look on this, yeah, because it will give you the ampere information. Yeah. It will be very useful when you are deciding what kind of battery, and when you are deciding the maximum takeoff weight of the multicopter. So how to choose the motor first? You have to know the total weight and the frame size. The total weight of the quadcopter should include all the components, yeah, the flight controller, ESC, motors, propeller, RX, video transmitter, antenna, lipo battery, GoPro, the camera, and so on. You have to put that on the scale and you write down the weight, and that is the very useful information to uh, decide what is the motor or what is the battery. Yeah, because thrust produced by all motor is at least double of the total weight of the quadcopter. That is the key when you are when you are building a multicopter. And this is the electronic speed controller, or ESC, um, usually using a MOSFET electronics here, and that is like a switching, and to make the three phase will work uh, each each point, and creating the rotating magnetic field so that the motor will rotate. Yeah. The higher frequency of the quicker of ASC goes through the six interval. The higher the speed of the motor will be the higher the speed. And this is the electronic speed controller as well. So you have three things that tend to increase your current. First is a higher motor kV. Yeah. When you have higher motor kV, you have to uh, put the ESG that follows the current of the motor. Yeah. So the larger motor size will be creating higher ampere. Yeah. And heavier propellers also creating also draw higher current as well. The key point here to deciding electronic speed controller is the current that draw on one rotor or one motor. And how we connect a motor? Yeah, so we just connect it because it has a three connection. And how to make it rotate clockwise and counterclockwise, or how to make it rotate on reverse. Yeah, so you have to change two of three cable here. So like in this diagram, so it will rotate on the opposite direction. And the proper direction, we have to take a look, because the propeller usually has some specific direction to use. There are two: motor spin clockwise and counterclockwise. And don't forget to see on the propeller which one is fit on the direction, on the right direction. And the propeller size, the length of propeller is the diameter of the disc. Yes, for example, when it's rotating, it creating a semicircular area, or the disc area that make it spinning. That is the length of the propeller. The pitch can be defined as the travel distance of one single prop rotation. For example, like a screw. Yeah, you can imagine it like the screw. One rotation, how long it will move axially. Yeah, that is the pitch. The multicopter can work if there is a flight controller. In the flight control, there are some sensors like accelerometer, gyroscope, barometer, compass, GPS. IMU we already discussed, yeah, and there is a barometer for knowing what is the uh, pressure of the air, the compass to know what the ground heading to, and GPS to know where the exact location, latitude of longitude of the drones. Yeah. This is the Arduino platform of the multicopter. This is the recommendation for you to learn multicopter, but not only for a user, but also as the developer. Yeah, if you want to develop a multicopter for a specific purposes, are you may be suggested to learn the Arduino pilot, yeah, because it is very first it's very easy. I think not really easy, but I think it's good enough to learn, and the information about it is so complete. Yeah, so you can learn yourself. And this is the block diagram of standard multicopter. You have propulsion system, power system, and camera and gimbal. Gimbal is the mounting system that makes the camera steady. Yeah? And also you have a video transmitter here. And we divide it as the multi-rotor and ground control station. Yeah. So the ground control station has a video receiver, video monitor, and maybe you will use a ground control with a PC or mobile device that connected to telemetry transceiver, and you use a RC transmitter as well. So this is the environment how the multi-rotor works. And the software, yeah. If you want to have the software that cheap, and also it can be developed by yourself. It's free. It's a mission planner software. It's also from Ardo Pilot as well. Yeah. Ardo Pilot, this one, yeah, you can just type it on Google and you will find the Ardo Pilot website, and you can download the mission planner software. With this software, you can create a drone that can do some tasks autonomously, and maybe you can put some waypoint, or you want to create a drone sprayer that are following the path. Yeah, you can use it by mission planner. And in the end, what is a drone application in agriculture? There are so many actually application, but I only discuss two of them that really hype uh, nowadays. It's a drone sprayer for agriculture. Yeah. So with drone sprayer, you can put some chemical on the crop plantation with a very efficient way, spread, and with a spraying drone, it represents technological advancement in modern agriculture, offering precise and efficient means of applying agriculture input to enhance crop protection and yield. With a GPS, digital mapping, and computer controlled spray mechanism enable these drones to optimize the application process, contributing to sustainable and effective management of agricultural resource. Because it is very efficient. If you are compare it with the manual spraying, it will be faster, it will be more precise, and you can put that drone on the task in very fast. Yeah, for example, you have a target, for example, 1 acre, 2 acre, or 20 acre on 1 hour or 2 hour. Uh, it can realize that we can realize that by sprayer. And on the right you can see what kind of the interface when you are creating waypoint on the crop plantation. And next is a drone for monitoring plant health. uh, Drones equipped with the special imaging equipment called, maybe some called a multispectral imaging. And we can get a NDVI, normalized difference vegetation index, from drone, because we use a detailed color information to put plant health. Yeah, for example, yeah, we can get a dead leaf, yeah, with this kind of spectral intensity, and stress leaf and healthy leaf. Yeah, we can distinguish them with the imagery, data imagery, and that is efficient if we are using a drone. So we can get the data and get the image data, and we put that on analysis. There are so many uh, software now that can analyze the NDVI data, and we can get the result that has a map that we can distinguish which one has a healthy leaf. Yeah, and we can distinguish them, and maybe we can put the specific dosage, put that on the spraying drone for precision farming. I think that's all the material that I could share. I hope it will be useful for you, and see you again.